Assalamualaikum and good day everyone. We from Group I. We will presenting our group project Waste to Resource Innovation through Composting of Food Waste for Sawi Cultivation Industry, a Circular Economy Study in Malaysia.
This is our group members.
Moving on to the introductions. To begin with, Malaysia is experiencing a rapid increase in solid and organic waste. Generation due to population growth, urbanization, expansion of industrial and agricultural activities. Number 2, Malaysia generates over 30,000 tons of municipal solid waste daily, 1.17 kg per capita. Food waste has the largest component, followed by plastics, papers, and other materials. Number 3, Malaysia generates about 8.3 million tons of food waste annually, 260 kg per capita, accounting for 44.5% of total waste, primarily from households and commercial sources. Number 4, this growing food waste problem indicates an urgent need to adopt circular economy strategies such as composting, which convert waste into valuable resources for local sawi cultivations. As shown in Figure 1, food waste currently dominates Malaysia's waste compositions compared to other categories. Thank you.
Malaysia consists of 50% food waste and 17% is disposed in landfill. High level of food waste burden landfill, causing significant pollution and methane emissions, which are a major contributor to greenhouse gases. At the same time, sawi cultivation depends heavily on chemical fertilizer, increasing production costs and degrading soil quality. Poor organic waste management leads to the loss of valuable nutrients that could be reused in agriculture while increasing reliance on imported fertilizer, affecting economic sustainability. Adopting a circular economy approach through composting can convert food waste into organic fertilizer, closing the resource loop and supporting sustainable local agriculture. Within the circular economy framework, waste is no longer viewed as a burden but as a valuable resource with economic potential. This project applies a circular economy approach by converting food waste into nutrient-rich compost fertilizer, thereby closing the material loop and promoting resource recovery. Effective waste-to-resource strategies support sustainable development by addressing environmental challenges while creating economic opportunities. The system closes the loop between food consumption and food production, reducing waste and resource dependency. By replacing part of chemical fertilizer use, the project promotes environmental protection, economic efficiency, and resource regeneration. By reducing reliance on imported chemical fertilizer, the project strengthens Malaysia's agriculture trade balance, support local green innovation, and promote a more resilient domestic economy.
In this section, I will explain how circular economy principles are applied through composting of food waste for sawi cultivation, focusing on reuse, recycle, and regenerate. First, for reuse, food waste is collected from households, restaurants, markets, and agricultural industries. Instead of being dumped into landfill, this food waste is prepared for composting while retaining essential nutrients and organic matter. This step allows nutrients to be reused within the system. It also reduces landfill disposal. At the same time, it supports sustainable agriculture under the circular economy approach. Next, for recycle, the collected food waste is processed through aerobic composting under controlled temperature and humidity. This process converts food waste into nutrient-rich compost that is suitable for sawi cultivation. By recycling food waste into compost, nutrients are returned to the soil and the use of chemical fertilizers is reduced. This process also helps close the material cycle within the circular economy system. Finally, for regenerate, the composted food waste is applied as an organic fertilizer to sawi farms. This application improves soil structure, restores soil fertility, and supports healthier sawi growth. Through this step, the nutrient cycle is fully closed and dependence on chemical fertilizers is reduced. Sustainable agriculture is strengthened in line with circular economy principle.
Innovative approach, composting for Sawi industry. First, food waste and collection separation. Food waste from household, restaurant and market is collected and separated. Convert food waste into high-quality, nutrient-rich compost. Faster processing with reduced odor, suitable for Sawi farm. Second, fast, efficient composting. Convert food waste into high-quality, nutrient-rich compost. Faster processing with reduced odor, ideal for Sawi farm. Aerobic composting with controlled temperature and humidity perceive nutrient. Modular unit in Sawi farm maintain consistent compost quality. Third, industrial and commodity integration. Collaboration with SMEs, cooperative and commodities for consistent supply. Tracking system from collection to application on the farm. 4. Circular application and sustainability. Food waste to organic fertilizer to Sawi farm to fertilize soil. Reduce chemical fertilizer and landfill, support circular economy. Process and procedure. First, organic waste. Sources. Food waste is collected from home, restaurant, market, and agriculture industry. Second, segregation. Food waste is separate from other waste at sources. Third, collection and transport. Segregated food waste is collected and transported to composting center. Fourth, retreatment. Food waste is separate, chopped, or dried. 5. Compost process. Aerobic composting control humidity and temperature, high quality compost fertilizer with reduced odor. 6. Resources recovery and process output. Final product or organic compost fertilizer. Compost compost is applied to Sawi farm. 7. Monitoring and evaluation. Fertilizer quality and application effectiveness are evaluated. Lastly, circular economy outcome. Nutrients are recycled, soil is fertilized, landfill is reduced, supporting sustainable agriculture and green economy.
Economic, environmental and trade impacts. First, in terms of economic impacts, composting helped reduce landfill management costs. Based on the report by MIDA 2005, composting reduced the amount of organic waste sent to landfills, which lowered disposal, operation and long-term maintenance costs. Second, composting can generate income from compost product. Based on study by Abu Shamala 2015, under the Green Biological Transformation of Food and Yard Waste project at UKM, composting food and yard waste produce compost product worth approximately RM30,660 per year, which can be sold to Sawi farmers and vegetable producer. This is further supported by Bioeconomy Corporation Malaysia 2025, which highlight composting as a value-add food waste conversion process. Third, composting support by growth of Malaysia green economy sector. According to UTM News Hub 2024, composting promote innovation in sustainable agriculture and encourage the development of green enterprise in Malaysia. Next, composting helps reduce dependence of import chemical fertilizer. Based on MIDA 2025, the use of locally produced compost lower reliance on imported chemical fertilizer, indirectly reducing farming costs and strengthening local agriculture inputs. Finally, composting helps create green jobs and local business opportunities. According to Business Today 2005, composting activities support the creation of green jobs and provide opportunities for local micro and small enterprise, especially in waste management and agriculture sector. Moving on to environmental impacts, composting provides several key benefits. First, in terms of land benefits, based on EPA 2025, Composting improves land quality by reducing soil erosion and enhance plants growth as well as overall biodiversity. Second, for soil benefits. Composting increases soil fertility, organic matter content and water holding capacity, which improve long-term soil health. Third, regarding water benefits. Composting reduces surface runoff and water pollution while improving soil water retention, helping to protect nearby water bodies. In addition, composting supports the circular economy and sustainable waste management. According to Dowmy 2024, food waste composting plays a key role in circular economy by adding value to waste material and promoting efficient resource management. Lastly, composting provides resilience benefit based on EPA 2025. Soil amended with compost are more resilient to drought and flooding and also help reduce greenhouse gas emission.
I would like to explain the three impacts of this study. First, reducing dependence on chemical fertilizer import. Local compost production helped reduce Malaysia's dependence on imported chemical fertilizers. By replacing imported synthetic fertilizers with locally produced compost, Malaysia can promote more sustainable agricultural practices while reducing reliance on foreign inputs. This reduction in fertilizer import contribute positively to Malaysia's trade balance by lowering import costs and strengthening the domestic agriculture sector. As a result, local farmers benefit from more affordable and environmentally friendly fertilizer options. Secondly, compost as a waste management solution. Composting serves as an effective waste management solution. Local composting initiatives help reduce the volume of food and agricultural waste sent to landfill. At the same time, this organic waste can be converted into high-quality compost fertilizers for local agricultural use, supporting a circular economy approach. This process not only reduces waste but also adds value to organic materials that would otherwise be discarded, supporting local industry growth and job creation. The composting industry supports local industry growth and job creation. The expansion of compost production and farmer training programs can generate new employment opportunities, particularly in rural areas. Increased demand for locally produced organic fertilizers stimulate the growth of the compost industry and contribute to local economic development. Overall, this supports a more resilient and self-sustaining agricultural economy.
Now, let's move to challenges and limitations of composting in Malaysia. First, economic and financial barrier. Composting facility require high initial capital investment, which limit participation by small-scale farmer and community-based initiatives. In many cases, compost production costs remain higher than chemical fertilizer due to proceeding, labor, and logistic expenses. Without sufficient financial initiative or subsidy, adoption of compost-based fertilizer remains slow, reducing the economic attractiveness of circular practice. Social and awareness issue. Public awareness of food waste segregation at source remain low. Participation from household, restaurant, and market is inconsistent. Negative perceptions such as composting being time-consuming and produce unpleasant odor reduce community engagement. This behavior barrier weaken the effectiveness of circular economy implementation at the grassroots level. From the figure 5, we can see community activity organized by Sutera follow. This activity can increase community knowledge about composting. Third, and market limitation. The domestic market for locally produced compost is still underdeveloped. Farmers are often reluctant to shift from chemical fertilizer due to concern over performance and reliability. Additionally, competitive with import chemical fertilizer, which are often subsidy and reliability available, affect compost pricing and market competitiveness.
Next is technology and infrastructure. First, many rural and urban areas still lack efficient composting systems. Most organic waste is sent directly to landfills instead of being processed into compost, mainly due to limited facilities and equipment. Second, there is limited access to temperature-controlled aerobic composting technology. Without proper temperature control, composting becomes slower, produces unpleasant odors, and may not reach the quality required for agricultural use. Finally, there is a lack of proper logistics and tracking systems from waste collection to farm application. This makes it difficult to ensure consistent supply, quality control, and traceability of compost products, reducing farmers' confidence in using compost. And last one is legal and regulatory challenges. One major issue is inconsistent waste management policies across municipalities. Different local authorities apply different rules, which creates confusion and makes it difficult to implement composting projects at a national scale. Another challenge is the lack of clear standards for organic fertilizer quality. Without standardized guidelines, compost products may vary in quality, making farmers hesitant to adopt them. Lastly, land use restrictions for composting facilities also limit expansion. Composting sites often face zoning issues or community opposition, which slows down project approvals and increases operational challenges.
In conclusion, Malaysia is facing a rapid increase in food and with to population growth, urbanization and expanding economy activities. Number 2, food waste constitutes the large component of municipal solid waste, placing significant pressure on landfill capacity. And number 3, poor food waste management contributes to environmental pollution and greenhouse gas emission, particularly methane. And number 4, the application of compost support sustainable sawi cultivation while reducing dependence on imported chemical fertilizer. And number 5, composting serves as an effective waste to resource approach by converting food into nutrient-rich organic compost fertilizer. And number 6, food waste resources remain underutilized despite their high potential for recycling and recovery. Thank you.
This slide presents a recommendation to strengthen the waste to resource composting initiative for sawi cultivation through a circular economy approach. For the first one, for the government, stronger policy support is essential. Authorities should enforce source separation of food waste at market, farms, and food premises to ensure cleaner organic input for composting. Financial incentives such as grants, tax exemption, and subsidies should be provided to compost producers and farmers who adopt compost-based fertilizers. In addition, circular economy principles should be fully integrated into national waste management and agricultural policies to support long-term sustainability. Next, for the industry and private sector, investment in efficient and scalable composting technologies is crucial. Industry should focus on producing and commercializing high-quality compost suitable for agriculture use. Particularly for sawi cultivation, the adoption of extended producer responsibility or EPR practices can further enhance food waste management by encouraging producers to take responsibility for waste generated along the supply chain. Finally, for NGOs and community groups, public engagement play a vital role. NGOs should conduct awareness campaign on food waste reduction and the benefit of composting. Communities and small-scale farmers should be trained in composting techniques and sustainable sawi farming practices. Establishing community-based composting centers can also support urban and peri-urban agriculture while promoting local participation. In conclusion, effective collaboration between the government, industry, and community stakeholders is key to transforming food and agriculture waste into valuable resources, supporting sustainable agriculture and circular economy in Malaysia.
This is our reference.
Good morning everyone. Welcome to our interactive mini game Pick a Flag.
Waste to resource for Sawi cultivation in Malaysia. Today we will test community knowledge.
Let's start.
And how to play? Each participant is given 8 color flag label A to H. The facilitator will read a question aloud and display it on a flag. You will have 20 seconds to raise our flag you think are correct. Each question may have more than one correct answer. Make sure to raise all correct flags.
Question 1. Which of following ways material are suitable for composting for mustard Sawi cultivation? Start.
Question number 2. Which of the following are the benefits of using compost in the mustard or Sawi cultivation industry from a circular economy perspective?
What are the main positive economic impacts of food waste composting for the mustard Sawi cultivation industry in Malaysia?
Question number 4. Which of the following are the environmental impact of food waste composting in Malaysia?
Question 5. Which of the following practice represent principle of the circular economy in the food waste composting of the mustard cultivation industry?
Now we will announce the winner of the mini games. For the third place is player 3.
Dah.
For the second place is player number 1. The winner for this game for first place is player number 2.
Okay. Thank you.
My name is Putri Aida. So today I will be interviewing one of the residents in my house area. Let's go. Okay, so first question. Do you know that food waste can be made into compost?
Yes, food waste can be made into compost and used as fertilizer for plants.
Next question. Is compost good for growing Sawi?
Of course, yes. Compost is good for growing Sawi because it makes the soil healthier and help the plants grow well.
Okay, for our last question. Do you agree that using compost can reduce waste in the village?
Yes, using compost can reduce waste by turning food waste into something useful instead of throwing it away.
Okay, thank you.
Welcome.
Good afternoon. I am a nursing student conducting a study on food waste management on circular economy practices in this area. This interview is voluntary and your responses will be used for academic purpose only. May I ask you for a few questions? Okay, question number 1. Do you separate food waste from other household waste in your daily routine? No, I usually throw all waste together because there is no proper separation system, even though food waste could be used as compost for raw vegetables such as Sawi. Okay, question number 2. If food waste were converted into compost, will you support this initiative? Yes, I would support it because the compost can be used to grow vegetables such as Sawi and also reduce the need for chemical fertilizers. Alright, thank you. Okay.